Hello, in this video I'm going to solve problems in quiz number 2, Mathematics 4. Question number 1. Consider this function. If the period of this function is t degrees and its amplitude is a, then t plus a is wanted. Okay, amplitude is just reading it from the function, but be careful, amplitude by definition cannot be negative, so this number is not exactly the amplitude. Absolute value of this number, which is 3, is the amplitude. That's it. So the amplitude is 3. But do you remember during the lesson we learned that the period in degrees is equal to 360 degrees divided by b. But what was b? B is the number that is multiplied by your variable x, in this case 4 over 3. So what I will do, I will replace b with 4 over 3. Of course, in this exam, a simple calculator was available, but I don't think we need a calculator here because this can be written easily as 360 degrees times 3 divided by 4. And now I can simplify 4 to 4 one times, this to 4, 90 degrees time, and then I multiply them so it becomes 270 degrees. But look, in the problem t is demanded, so t is the pure number without the degree sign. So if t degrees is equal to 270 degrees, t simply becomes 270. And the question mark, which is t plus a, is simply 270 plus 3, which is 273, and this is the answer to this problem. So that you have to type here 273. Question number 2. If tangent theta equals 5, then tangent theta minus 180 degrees plus tangent theta plus 180 degrees is equal to what? Okay, so you need to write that since 180 degrees is the period of tangent theta, tangent theta plus or minus 180 degrees is equal to tangent theta. Yes? So this means that this number and that number are also equal to tangent theta, and that is equal to 5. So the question is very simple. So I have to write 5 plus 5 plus 5, which is simply 15, and 15 is the answer that I have to type in the box. Okay, question number 3 now. In an alternating current circuit, the voltage V in volts can be expressed by the equation that you see here, where t is the time in seconds since the power source was turned on. The voltage at t equals to 4 milliseconds, rounded to 1 decimal point, is equal to how many volts? The second part of the question, the period of the alternating voltage is what? Okay, so this problem is actually very simple. So the first one, what I need to do is just replace t with the t given and calculate the voltage. The only thing that you have to be careful, the model is expressed in which time is measured in seconds, but this time is in milliseconds, so you have to change the milliseconds to seconds, which is very easy. So t is equal to 4 milliseconds, which is equal to 4 times 10 to the power of minus 3 seconds. Okay, so for the first part of the problem, I just need to put this number inside the formula. So 3 sine, I have 100 pi, and multiplied by time. Time is 4 times 10 to power minus 3 seconds, and then I have minus pi over 2. Okay, so the only thing that now I can do is to take this into the calculator and do the calculation. Okay, since I have only given you access to the calculator on exam.net, so let me myself use the same calculator. One thing that you have to be very careful about here is this one. This is now in degree mode by default. But you know that the calculation in this problem should be done in radians. So what I need to do, I go to this angle button and click on it. So then what will happen, this becomes in radians. Okay? Okay, so what should I type? I just type this expression in. You have to be careful in typing. So we have 3 and then multiplied by sine. Sine is under this tab. Sine function is here. Sine of 100 multiplied by pi, which is this, and then multiplied by 4 multiplied by 10 to the power of minus 3. So you go to the default one and then you have the power here. So you just type 10 and then to the power of minus 3. And then because the pair of a bracket was opened, so I have to close it as well. And then minus pi divided by 2, and I close it and I press equality sign and I get the number here, which is minus 0.92. Yes, but because I am supposed to round it into 1 decimal point, the answer to the problem is simply minus 0.9 volts. But because the volt is already typed here, so what you need to type there is just simply negative 0.9. But of course, for the second part of the problem, I need to find the period of the alternating voltage and express it in milliseconds. So you know that this is the B coefficient, and this has something to do with the period. So the period in radian mode is 2 pi divided by that B. So it becomes 2 pi, but the B in this problem is 100 and pi, and it doesn't need calculator. Okay, so this pi and that pi are gone. 2 over 5 is simply 1 over 50, but this is in seconds. I want to express it in milliseconds, so I multiply it by 1000, so it becomes 1000 over 50 seconds. But this is also simply 20. Oh, sorry. This is in seconds. This becomes now in milliseconds. So this becomes just 20 milliseconds. And then milliseconds is already typed here. So what you need to do is just to type 20 there. Okay. So now we go to the next question. Okay. Now we go to question number 4. Consider the following equation: square root of 5 times sine 3x plus square root of 11 times cosine 3x equals 2. If the solutions of this equation are rounded to the nearest integer degree, the sum of the solutions within the interval 0 degrees and 180 degrees is equal to what? Okay, so you need to remember that this is a famous combination in trigonometry as we had it in the lesson, and then you need to go and read the suitable formula in the formula sheet, which is something like this: a sine theta plus b cosine of the same theta, if of course a is positive, this formula only works if a is positive, is equal to square root of a squared plus b squared multiplied by sine of the same angle theta plus a constant c, where the constant c has this relation: tangent of that constant c is the coefficient b divided by coefficient a. So this is the suitable formula that you have it in the formula sheet and is useful for this problem. If you realize that you can give the role of the coefficient a to square root of 5 in this problem, and this b and this 3x that appears here and there, I can give the role of theta to that 3x. And I use this formula to rewrite the left hand side in a way that is only one sine function. So let me calculate that one first. So here what I will do, I would say that the left hand side is equal to square root of a squared, but a squared in this problem, square root of 5 to power 2 is 5, plus b squared is 11. And then I have sine of theta in this problem, theta is 3x, and the constant c. But let me write it a little bit simpler. 5 plus 1 is 16. Square root of 16 is simply 4, so it becomes 4 sine 3x plus c. And what is tangent of c? Tangent of c, according to the formula, is b, which is the square root of 11 in this problem, divided by a, which is the square root of 5. Of course, c itself becomes tangent inverse of that, but don't be in a hurry and don't put it here. So let us do it later at the very end that we want to do the approximation. So for the time being, I just work with letter C for simplicity of writing. Okay, so I will go to my equation, remove this, and replace it with that equals to 2. So my equation becomes now 4 sine 3x plus c equals to 2. I divide everything by 4, so sine 3x plus c becomes 1/2. And again, you know that 1/2 is a famous number for sine in trigonometry. So if I want to find if I want to solve this equation, so 3x plus c becomes sine inverse of 1/2. If you don't remember, you can look it up in the table. It is 30 degrees plus n times 360 degrees. Of course, I will also have another alternative, and that is 3x plus c is 180 minus 30, which is 150 degrees, plus n times 360 degrees. In both cases, I need to calculate x, so I move c to the other side, becomes minus c, but I have to divide everything by 3. 30 divided by 3 becomes 10. C moved to the other side, minus c divided by 3 becomes minus c over 3, and 360 degrees simply becomes 120 degrees. The other one the same, but this time 150 divided by 3 becomes 50 minus c over 3 plus n times 120 degrees. Now it is a good time to go to the calculator and calculate this number c over 3. So it means that I have to calculate c, which is tangent inverse of square root of 11 over square root of 5. But because I want c over 3, I multiply it by 1/3. This is the number that I use the calculator to find the answer. Okay, so let us open up the calculator here. Okay, check it. Yes, it is in degree mode. So what I have to do, I have to type this number within my calculator. So 1 over 3, this is 1 over 3 multiplied by tangent inverse. You go to this more. Tangent inverse in exam.net calculator is denoted by auton, so I just press that one. And then I have to go back to have access to a square root sign. Square root of 11. Don't forget to close the pair of bracket, bracket, and then divide by a square root of 5. Close it for square root sign, but you also have to close it for auton. Now everything is ready. I hopefully, yes, double check, yes, it's correct. So 18.67. So I want to round it up to the closest integer, so the answer will be 19 degrees. So the answer that I have to write here is 19 degrees. Okay? Now what we will do, we will actually take this number, 19 degrees, and put it here. 10 minus 19 degrees is minus 9 degrees. So it becomes minus 9 degrees plus n times 120 degrees. And if I put 19 degrees here, 15 minus 19 is 31 degrees plus n times 120 degrees. And because we don't need the calculator anymore, probably, so let me open up some space now. Okay, now I need to find the angles within this interval. So what I will do, I have to choose appropriate values for n, integers of course. But here, for example, I cannot choose any negative integer because the angle will be negative, which is not acceptable. Even 0 is not acceptable in this case, because if I put 0, this is gone. Minus 9 degrees is still negative, is not acceptable. So the only choice that I have is 1. Yes, because if I put 1, it becomes 120 minus 9, which is 111 degrees. So let me register it here. And if I put 2, it becomes 240 minus 9, which is beyond 180 degrees, not acceptable. So I have to switch to the next formula. In the next formula, again, I cannot put negative values. If I put 0, this one is acceptable. If I put 0, this is gone, and I get 31 degrees. So let me also register it here. And then finally, if I put 1, it's still acceptable because 1 becomes 31 degrees plus 120 degrees becomes 151 degrees. But if I put 2, it goes beyond 180 degrees. So the question mark is just summing these numbers up, adding these numbers up, yes? So what is the answer? 142 plus this one, 293 degrees. And this is the answer, but the degree sign is typed by me here. So the only thing that you have to write there is 293. Okay, let us go to the next question now. Okay, next question, number 5. If the following figure, as you see here, portrays part of the graph of the function y equals to a sine bx plus d, then a plus b plus d in decimals is demanded. Okay, so let me make the picture a little bit bigger for you here so that we can see it better. So this is a very standard problem. So in order to find a, we have a formula. For finding b, we have a formula, and b is related to the period. A very, very standard problem. Okay, so now, but for a and d, I need to know what is the maximum and what is the minimum of this function. That is very easy to see because they have told us that this grid point is 2, so it means every grid point is 1. So 1, 2, 3, 4, 5, 6. So that's the highest value. So y max is 6. So let me register it here. And the lowest value is minus 1, minus 2, it's here. So the lowest value is minus 2. Okay. And what the period is? The period is, for example, the distance between two consecutive crests. So the consecutive crest, this is the first crest, and this is the immediate crest after that. So I need to know the distance from here to here, which is one full period. So this is my period here. And if I want to read it, it is very simple. This one is 100 degrees, so every grid is 100 degree. So 1, 2, 3, 4. So t is 400 degrees. Now, using these pieces of information, I can immediately answer all the unknowns a, b, and c. So let us go back to the original size now. So do you remember the formula for y? The formula for a. A was y max minus y mean divided by 2, which of course in this case y max is 6, yes, and then the minus y mean, which is minus 2 divided by 2, so it becomes 8 divided by 2, so a becomes 4. So a is 4. And for d, we know that it is y max plus y mean divided by 2, but y max is 6 plus minus 2 divided by 2, so 4 divided by 2, so d is simply 2. Okay, and then what I have to do, I have to calculate b. So what is b? The formula for t is equal to 360 degrees divided by b, yes? But we already learned what t is. T is 400 degrees is equal to 360 degrees over b. But I am looking for b, so b becomes simply 360 degrees over 400 degrees, Of course, you have access to calculator, but you really don't need to do that. The degree signs are gone, that becomes a pure number, and then I divide everything by 10, for example, it becomes 36 over 40, and I divide by 4, so it becomes 9 over 10. And 9 over 10 in decimals is just 0.9. And now the question mark is asking for a plus b plus d. So then it becomes a is 4, b is 0.9, d is 2. So if you add them up, it becomes 6.9. That's the correct answer, and that you have to type it here, 6.9. Very simple and a standard problem. We practiced about these kinds of problems a lot during the lesson. Okay, we now go to the next question. Okay, question number 6. In a 5-hour endurance race, a runner's speed is modeled by the following formula. V of t is equal to 50 divided by this trigonometric function, where v is the speed of the runner in meters per second and t represents time in minutes since the start of the race. According to this model, rounded to the closest integer, after how many minutes does the runner's speed reach to its minimum? I hope that you agree with me. This is the same famous combination that we had in the previous exercise. So this can play the role of A, this can play the role of theta, and this can play the role of B, and A is positive, so that formula can also work here. So let me simplify my model a little bit by using that formula. So the denominator, so let me write the denominator is equal to square root of a squared, which is 144 in this case. So this is a, this is b, and then plus 25, and then you have sine of your angle, which is 2/5 t degrees. If you don't mind, let me write it in this way, plus a constant c. But what is c? Tangent of c is equal to that number b over a, which in this case is 5/12. Okay, but let us keep it, and for simplicity of writing, I can do the calculations later. But this number can be simplified more, because 144 plus 25, 169, you can use the calculator, or if you have it in your memory, it becomes 13. So this is just simply 13 sine 2/5 t degrees plus a constant c. Okay, so if this question, by the way, is well defined, because you know that in physics when we talk about speed cannot be negative. Technically speaking, this function can be a negative. Sine function can be positive or negative because it's oscillating up and down. But the point is that in 5 hours, this shouldn't be negative, because otherwise the speed becomes negative and it is not defined. So how should I make sure that this is not going to happen? I need to have access to how much the value of c is. But if t is between 0 and 5 hours, and because t is represented in minutes, so we know that t is somewhere between 0 and 300. 5 hours means 300 minutes. And if I multiply this by 2/5, so the left hand side becomes 0, the middle one becomes 2/5t, and the other one becomes 120. Yes, so 2/5. Okay, so it means that in order to guarantee that this function is positive, I should guarantee that this angle is in the first or in the second quadrant, because sine is positive in the first and second quadrants. So this means that this c should be definitely less than 60 degrees, because if it is more than 60 degrees, when added to this, it will go beyond 180, so it will go to the next quadrant, which makes sine negative. But that is also probably not hard to see if you compare this number with the square root of 3/2, which is the tangent, with the square root of 3, which is the tangent of 60 degrees. And then you will see that this number is indeed smaller than square root of 3, so this angle is definitely less than 60. So everything is well defined here. But of course, this what I'm describing now is not part of the solution of the problem, okay? So you don't even need to bother this. So this is not necessary. Let me put it in something that you really don't need to even pay attention to it. But I just want you to understand the problem completely. This is a good observation to make. Okay, so now we understand that the denominator within this range is positive. The numerator is also positive. You want to minimize your quantity, so it means that I have to maximize the denominator because the numerator is fixed. To maximize the denominator, I have to make this one equal to 1. Yes, because the maximum value of the denominator is 13, and it occurs when this expression is 1. So in other words, I have to solve this problem. 2 over 5 t degrees plus c equals to 1. And because it is in degrees, you know that 2 over 5 t degrees plus c should be 90 degrees plus any, of course, multiple of 360 degrees. And I need to find t, so it becomes, I moved c to the other side and I multiply, so let me write it in 2 steps. So it becomes this, and it becomes 90 degrees minus c plus n times 360 degrees. I am looking for t, so I multiply everything by 5 over 2. So if I multiply this by 5 over 2, so it becomes 225 degrees. Yes, you can use, of course, calculator. So if I multiply 90 by 2 over 5, so no, by 5 over 2, 90 by 5 over 2, so this one and this one simplified, 45 degrees times 5, so it becomes 225 degrees. And the other one will be multiplied by 5 over 2c, and then if I multiply 360 degrees by 5 over 2, this one and that one are cancelled, 180, so it becomes 900 degrees. Yes, so it becomes plus n times 900 degrees. Okay, so this is the time that we eventually need to calculate this one. So what I will do, so here from this relation I can calculate my c. So c is tangent inverse of 5 over 12, but I need to calculate 5 over 2 of it, so I multiply this by 5 over 2. So let me go to the calculator now, and then I type that number there. So I want to type this number in my calculator, so let me, you can open a pair of brackets here, and 5 divide, of course it is not necessary here, and then multiplied by tangent inverse, as I told you before, tangent inverse is here, and then I have 5 divided by 12, and I close this one. It is also in degree mode, this is important to check, and then I press enter or equality to see if I have done it right, but I want to round it to the closest integer, so it becomes 57 degrees. No, sorry, yes, 57 degrees. Okay, so this becomes 57 degrees. This is the answer that we get here. Now that I don't need calculator anymore, so let me take it off. Yes, to open some space. Now what I will do, I will take 57 degrees and put it here. So then t degrees becomes equal to 225 degrees minus 57 degrees plus n times 900 degrees. And now I drop all the degree signs to find the pure number t. So this number, this one minus 50 is 168. Yes, this number is 168, and then plus n times 900 degrees. Of course, I have to be within the range between 0 and 300. So If I choose negative value for n, it will not work, it becomes negative. If I choose 1, 2, etc., etc., it will not work, it will go beyond 300. So the only choice that I have is n equals to 0, and it gives rise to 168 minutes. So this is the answer. So this means that I have to choose this option. Yes? Okay, so now let us go to the next problem. Okay, finally, question number 7. Consider the following figure. If the blue curve is part of the graph of the function y equals to a sine 2x plus b cosine 2x plus c, the value of this expression is wanted. Okay, so the way that I do it, I will try to find a sine function first that fits this graph. Okay, so I would do this. Y equals to, because I have already used capital A, capital B, capital C in the problem, so don't to get confused, so let me use little a sine little bx plus little c plus d. So my goal is to write an equation of this for the curve. You can use cosine, but I usually prefer, if I'm not forced to use sine. For me it is simpler. Okay, but for A and D we have a formula, so we have to read the maximum and minimum values here. So the maximum occurs here because every vertical grid is 2 units, so this is 4. And now this is -2, -4, -6, -8, so the minimum value is also -8. So immediately I can find A and D at least. So A is y max minus y mean divided by 2. So which is y max 4 minus -8 divided by 2, 12 divided by 2, 6. Yes, and then D is y max plus y mean divided by 2. Yes, so y max is 4 plus -8 divided by 2. -4 divided by 2 is just -2. Okay, so another thing that this D will help me is the guiding line. So y equals to D is the guiding line. If you remember from the lesson, is y minus 2. So let me draw that as well. So this will help me to read the period. Why is that? Because the period, I need to read the period in order to find B, but the period is the distance between two a trough and an immediate crest coming after that or before that. But the problem is that these points are not grid points, so I cannot take the risk to read them like that. I have to use the grid points exactly. But then I know that, of course, another way to read the period of a sine function, if you know that this is the guideline, if this is the x-axis, so from here to here is also one period, so this one is half a period. So that I can read from here. This is half a period. So 3 grids is half a period. So the period is 6 times the horizontal grid, but every grid on the horizontal axis is pi over 6. So the period is 6 times pi over 6, which is just simply pi. On the other hand, we know that the period is 2 pi over the constant b. So this means that pi is equal to 2 pi over b. So simply b becomes 2. So what do I have so far? Y is equal to, instead of a I put 6, sine instead of b I put 2, c is still not known, and then -2. But c is related to the horizontal shift, so you know before doing that you have to factor a 2 out, because shift is the amount which is added to c, to x, not to 2x. And this is the case. So the amount of shift is c over 2. But now compare it, because you have the guideline, you can pretend this is your x-axis, and of course this is your y-axis. The normal sine 2x function goes from the origin, but now this has started from a little bit behind. How much behind? 1 grid to the left. So it should be positive, and it would be pi over 6. So then it means that c is pi over 3. Yes? Okay, now everything is ready. So y is equal to 6 sine 2x. I got c to be pi over 3, and then I have minus 2 at the end. But now this is not of this form yet. But now I use addition formula for sine to expand this expression. So it becomes 6, open a pair of brackets. Do you remember sine of the sum of two angles is the sine of the first one, cosine of the second one, plus the other way around, sine of the first one, cosine of the sine of the second one, cosine of the first one. And then of course you see that I have a minus 2 at the end, so I will type minus 2 as well. But you know that this number is famous. You can look it up in the table. It's 1/2. This one is square root of 3 over 2. I have to multiply 6 in. So when I multiply 6 in, 6 times 1/2 becomes 3. So it becomes 3 sine 2x. 6 times the square root of 3 over 2 becomes what? 3 square root of 3 cosine 2x. But I have a minus 2 at the end. Now just you need to compare this function with the function given. It is easy to see that capital A is 3, capital B is 3 square root of 3, and capital C is minus 2. Yes, so capital A is what? Is 3, capital B is 3 square root of 3, and capital C in this problem, is minus 2. Now let me open up a little bit of space here to calculate the final part. The question mark is A, which is 3, plus 3 square root, plus square root of 3 times your B, but B itself is 3 square root of 3, and finally C is plus minus 2. So this becomes 3 square root of 3 is 3 times 3 is 9, and minus 2, so it becomes 12 minus 9, which is 10. So the answer that we are supposed to type here in this empty box is just simply 10. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.